There's a moon in our solar system that can shock you with electricity from 2,000 kilometers away, and it does not even have a power source. It has no engine, no battery, no wires, just ancient ice, cosmic dust, and a surface so strange that scientists still argue about how it even exists. This moon does not spin the way every other moon in the solar system spins. Its rotation is so chaotic that nobody, not the best supercomputer on Earth, can predict which way it will be facing more than a few weeks from now. If you stood on its surface, the sun would not rise in the east and set in the west like it does here. It could zigzag across the sky, freeze in place for days, then suddenly drop below the horizon without warning. This is not science fiction. This is a real place, orbiting Saturn right now, and its name is Hyperion. And by the end of this video, you will understand why scientists call it one of the most genuinely bizarre objects ever studied up close by a spacecraft. Hyperion is the largest of Saturn's irregular moons, sitting about 1.5 million kilometers from its parent planet, tumbling through space with a motion so chaotic that predicting its future orientation is almost impossible. Unlike most of Saturn's confirmed moons, and Saturn now has more than 290 of them, Hyperion is not smooth and round. It is jagged, porous, and irregular, like a giant frozen sponge floating in the void. It is a world that breaks nearly every rule of planetary science that we thought we understood. Voyager gave us the first hints of a violent past, a massive crater visible even from a distance. But it was not until the Cassini spacecraft flew close to Hyperion in 2005 that the full picture came into focus. Complex gravity, an ancient collision between proto-moons, and a bizarre internal composition combined to make this arguably the strangest object anywhere in the Saturn system. And yes, it really can zap a spacecraft with electricity from thousands of kilometers away. We will get to that unbelievable part later, so stay with me, because it gets even more surprising from here. Let's go back to how this strange world was even discovered in the first place. To understand Hyperion, we have to travel back to the middle of the 19th century, a golden age for observational astronomy, a time when our understanding of the solar system exploded thanks to massive leaps in telescope technology during the 1840s. Teams of astronomers all over the world were racing to find new objects in the sky, and the discovery of Hyperion was not a single clean moment. It was actually a two-way transatlantic tie between two separate teams who found it within days of each other. On the evening of September the 16th, 1848, at the Harvard College Observatory in the United States, the father and son team of William and George Bond spotted a faint object that did not match any existing chart of Saturn's moons. William Cranch Bond did not have a formal education in astronomy, but he worked his way up through pure dedication to become the very first director of the Harvard Observatory. He was using its brand new 15-inch equatorial refractor, one of the most powerful telescopes anywhere in the world at that time, when he and his son first noticed this strange new object near Saturn. Just 2 nights later, thousands of kilometers away across the Atlantic Ocean, a wealthy British brewer named William Lassell, who had poured his fortune into astronomy instead of just his business, independently made the exact same discovery. He was using a 24-inch reflecting telescope of his own design. What could have turned into a bitter dispute over who deserved credit instead became something much more graceful. Because the two discoveries happened so close together in time, the astronomical community eventually agreed on something rare, a triple credit discovery, honoring both Bonds and Lassell together for finding the same moon almost simultaneously from opposite sides of an ocean, with no way to communicate instantly like we can today. The moon was soon named following a suggestion from the astronomer John Herschel, who proposed that Saturn's moons should be named after the Titans, the mythological siblings of Kronos in Greek mythology. Hyperion, the Titan associated with watchfulness and observation, turned out to be an oddly fitting name for a moon that, as we would later discover, never looks quite the same way twice. In fact, this moon was strange from the very beginning. It was the first non-spherical moon ever discovered in our solar system, and as we learned more about it over the following decades, things only got stranger from there. Now, here is something that might genuinely surprise you. Hyperion is basically empty inside. It is a world that refuses to fit into any neat category. It is one of the largest bodies in the entire solar system, with a highly irregular shape, a strange status it shares with only 2 other objects, Neptune's moons, Proteus and Nereid. Among Saturn's moons, Hyperion ranks as the 8th largest by radius, but curiously only the 9th most massive. That mismatch is not a coincidence. It is a clue pointing directly to its bizarre internal structure. And thanks to data gathered by Voyager back in the 1980s, we also learned that it rotates chaotically, unlike anything else nearby. While we usually picture moons as smooth, spherical mini-planets, Hyperion looks nothing like that at all. It is a battered, elongated mass that scientists and space enthusiasts have compared to a potato, a giant burger, and even a deflated football drifting through space. But why exactly does it look and behave this way? One of the strangest facts about Hyperion involves its density. It sits at approximately 0.54 grams per cubic centimeter, which makes this moon only about half as dense as liquid water. Even when compared to pure water ice, which has a density of roughly 0.92 grams per cubic centimeter, Hyperion still comes out far lighter than expected. This tells scientists that it simply cannot be one solid block of ice and rock. Instead, it is most likely what researchers describe as a pile of rubble. If you somehow stood on its surface, the ground beneath your feet would not feel solid at all. It would feel like a fragile, honeycomb lattice made of ancient water ice and dark organic dust, barely holding together. Data gathered from the Cassini mission suggests that more than 40% of Hyperion's interior is literally empty space. Let that sink in for a second. Nearly half of this entire moon is just gaps and holes, held together loosely enough that it should not even be able to keep its own shape, and yet somehow it does. This extreme porosity is almost certainly a leftover clue from how Hyperion originally formed. Unlike larger moons that went through a process called differentiation, where internal heat melts the interior and allows heavier materials to sink down toward a solid core, Hyperion most likely never stayed warm enough for long enough to compact itself into anything solid. Instead, it remained a primitive, loosely bound collection of debris, possibly even the reassembled remains of a much larger object that scientists call proto-Hyperion, a body that may have measured around 1,000 kilometers across at one point. A massive, violent collision likely shattered this original world, leaving today's Hyperion as the largest surviving fragment. The rest of that ancient debris may have rained down onto the nearby moon Titan, or been ground down into the dust that now forms Titan's strange orange-colored dunes. But this bizarre internal structure is not just an interesting fact about Hyperion's past. It directly shapes the moon we see today. Because of how porous and lightweight it is, Hyperion has an extremely low escape velocity. In fact, a professional baseball pitcher could very nearly throw a ball hard enough to launch it into orbit right from Hyperion's surface. On top of that, the moon's spongy interior acts almost like a natural shock absorber, and this single fact explains why Hyperion looks the way it does from the outside. When the Cassini spacecraft performed its close flyby of Hyperion back in 2005, the images it beamed back to Earth were unlike anything scientists had ever seen before on any moon. The entire surface was covered in deep, sharp-edged pits, giving it the unmistakable appearance of a wasp's nest or a sea sponge frozen solid in space. On a typical rocky moon, like our own moon orbiting Earth, an asteroid strikes the surface at several kilometers per second, releasing its kinetic energy in a violent explosion that carves out a crater, blasting debris outward to form a raised rim and a surrounding blanket of scattered material. On Hyperion, this entire process works completely differently. Because the moon is so incredibly porous, an impacting object does not blast material outward the way it normally would. Instead, it compresses the surface inward. Picture firing a small pebble into a thick block of styrofoam. The material gets pushed downward and packed in on itself, creating a deep pit without the usual raised rim or the typical spray of ejected debris you would expect from a normal impact. And because Hyperion's gravity is so incredibly weak, any material that does get kicked up during an impact has a very high chance of reaching escape velocity entirely. Instead of falling back down to refill old craters or blanket the landscape in a fresh layer of dust the way it would on most other moons, that material simply drifts away into orbit around Saturn and never returns. This keeps Hyperion's surface remarkably clean, preserving the crisp, sharply defined shapes of its ancient craters for billions of years without them ever softening or filling in. The end result is one of the most crater-saturated surfaces found anywhere in the entire Saturn system, a landscape that looks almost alien even by the standards of other moons. These craters are absolutely spectacular to look at, and honestly, Hyperion really does resemble a sponge when you see the real images. But the strange, sponge-like surface is far from the only bizarre thing this little moon has to offer. Hyperion also moves through space in a way that no other body in the solar system does. Hyperion does not exist in isolation. Its entire existence is shaped and constantly influenced by its much larger neighbor, the moon Titan. Titan is an absolute giant, the second largest moon in our entire solar system, and its powerful gravitational pull dominates everything in its neighborhood. Hyperion and Titan are locked together in what is called a 4-to-3 orbital resonance, which simply means that for every 4 complete orbits Titan makes around Saturn, Hyperion completes exactly 3. This kind of resonance is essentially a delicate, ongoing gravitational tug-of-war between the two moons. Every time they pass close to each other, Titan's massive gravity gives Hyperion a periodic gravitational kick. This interaction produces 2 major effects on the smaller moon. First, Titan's gravity prevents Hyperion's orbit from ever settling into a smooth, circular path. Instead, Hyperion follows a stretched out, egg-shaped orbit that carries it much closer to Saturn at some points, and much farther away at others. Second, the combined influence of Hyperion's irregular, elongated shape together with the constantly shifting gravitational pulls from both Saturn and Titan pushes the Moon into a genuine state of dynamical chaos. In most of the solar system, gravity behaves almost like a giant, reliable clock, allowing astronomers to accurately predict the positions and orientations of planets and moons centuries into the future with remarkable precision. But that reliable clock completely breaks down when it comes to Hyperion. Back in 1984, a planetary scientist named Jack Wisdom, working alongside colleagues at MIT, built new mathematical models specifically designed to predict Hyperion's motion, trying to figure out exactly why this moon tumbles unpredictably instead of spinning smoothly like nearly everything else out there. What they discovered was genuinely remarkable. Hyperion's rotation turned out to be so extremely sensitive to tiny changes in its environment that its orientation becomes essentially unpredictable over timescales as short as a single month, a limit scientists now refer to as its Lyapunov time. In simple terms, we literally cannot reliably predict which way this moon will be facing more than a few weeks into the future, no matter how powerful our computers become. Hyperion is the only large moon anywhere in the solar system known to lack a stable spin axis in this way, and it stands as one of the very first confirmed examples of true chaotic motion ever discovered anywhere in the cosmos. If you somehow found yourself standing on its surface, the sun would not rise smoothly in the east and calmly set in the west the way we are used to. Instead, it might zigzag unpredictably across the sky, drift backward for a while, hang completely still for days at a time, and then suddenly plunge below the horizon with no warning at all. But beyond its bizarre physical structure and its wildly erratic tumbling motion, Hyperion is hiding an even deeper secret, one buried in its chemistry rather than its shape. One of the most important scientific instruments carried aboard the Cassini spacecraft was called the Visual and Infrared Mapping Spectrometer. Its entire job was to carefully map out the composition, temperature, and physical structure of Saturn and its many moons. When scientists finally turned this instrument toward Hyperion, it revealed a genuinely complex mixture of water ice combined with organic compounds. The bright walls, found inside Hyperion's many craters, are primarily made of crystalline water ice, chemically fairly similar to the ice we are familiar with here on Earth. But the dark material, sitting at the bottom of those same craters, is something else entirely, a thick slurry of hydrocarbons mixed with organic dust. Dale Cruikshank, a planetary scientist working with NASA, has pointed out that these particular hydrocarbons share the same basic chemical building blocks found inside comets and meteorites drifting through our solar system. So where exactly does all of this dark material actually come from? To answer that question, we have to look further out into the Saturn system, toward a completely different moon called Phoebe. Phoebe is a dark, backward orbiting moon believed to be an object originally captured from the distant Kuiper Belt, the same far-flung region of space that gave us the dwarf planet Pluto. Phoebe is also the source of an enormous, almost completely invisible ring of dust that quietly orbits Saturn at a great distance. As particles from this dust ring slowly spiral inward toward the planet, they end up being intercepted by various other moons along the way. Iapetus, sometimes nicknamed Saturn's yin and yang moon because of its dramatically two-toned surface, catches the majority of this incoming dust on its leading hemisphere. But a portion of that same dust manages to slip past Iapetus and eventually lands on Hyperion instead. Because Hyperion is constantly tumbling in a chaotic, unpredictable way, it does not have a single consistent leading side facing forward like most moons do. This means the dark material arriving from Phoebe ends up spreading out much more evenly across Hyperion's entire surface, although it naturally tends to settle and accumulate down inside the low points of its many deep craters. One of the other genuinely fascinating discoveries made during this research was that the carbon dioxide found on Hyperion is not simply pure, ordinary dry ice. Instead, it exists in what scientists call a complexed state, chemically bonded or attached to other surface materials around it. This unusual bonding actually makes the carbon dioxide far more stable overall, preventing it from slowly evaporating away into space, even across the staggering 4.5 billion year history of our entire solar system. The presence of these particular molecules, especially when they are exposed to ultraviolet light from the sun, can gradually lead to the formation of even more complex molecules, the kind considered biologically significant by scientists. Now, to be very clear, this does not mean that Hyperion harbors any actual life, but it does prove something genuinely important, that the basic chemical ingredients needed for life to potentially arise are far more widespread throughout the universe than we once assumed, showing up even on a strange, battered little sponge moon orbiting Saturn. Now, everything we have covered so far paints a picture of Hyperion as an undeniably odd, chaotic little world. But there is one single discovery that Cassini made about this moon that I personally find absolutely shocking. And it did not come from its cameras at all. It came from its plasma instruments, the sensors designed to detect charged particles in space. Hyperion has no atmosphere whatsoever, which means its surface is constantly bombarded by solar radiation and fully exposed to the harsh, punishing environment inside Saturn's powerful magnetosphere. It is relentlessly pelted by a steady rain of charged particles streaming from the planet's magnetic field. Combined together, these forces cause massive electrostatic charges to gradually build up across the moon's surface, particularly near what scientists call the terminator, the sharp boundary line separating day from night on the moon. This buildup is fundamentally similar to the static electricity you might feel after rubbing a balloon against your hair, except this is happening on a truly planetary scale. And in 2005, this buildup of static charge spelled real trouble for the Cassini spacecraft passing nearby. In 2014, nearly a decade after that original flyby, a new detailed analysis of the data revealed something genuinely astonishing. Hyperion had actually reached out and zapped the Cassini spacecraft with a beam of electrons during that 2005 pass. At a distance of roughly 2,000 kilometers above the moon's surface, Cassini happened to pass directly through magnetic field lines connected back to Hyperion itself. For a brief moment, the spacecraft and the moon became magnetically linked, and Cassini received the equivalent of a 200-volt electric shock, roughly comparable to accidentally sticking your fingers directly into an electrical socket, which, just to be clear, you should never actually try. This moment marked the very first time scientists had ever detected a charged surface on any moon in our entire solar system other than our own. Thankfully, this unexpected electrical shock did not cause any lasting damage to Cassini, but the discovery carries serious implications for any future missions we send to explore places like this. Static charging like this can cause fine dust particles to actually levitate and drift across a moon's surface, potentially coating sensitive scientific instruments, or even escaping the moon entirely and floating off into space. For any future robotic probes, or even human explorers eventually visiting similar environments, these unpredictable electrostatic discharges could pose a genuine hazard to delicate electronics on board, meaning we will likely need to design future spacecraft that are specifically hardened against the electrical charges present on the worlds they are sent to visit. So when you step back and look at everything together, Hyperion shows us that our solar system is far more than just a tidy collection of smooth, predictable spheres quietly orbiting the sun. It is a place shaped by ancient violence, genuine mathematical chaos, and unexpectedly complex chemistry, all wrapped up inside one small, battered moon. From its bizarre, sponge-like surface that quietly absorbs the impact of the cosmos without scarring in the usual way, to its wildly unpredictable tumbling rotation that defies our very best scientific equations, Hyperion remains a world that keeps astronomers humble even after more than a century and a half of study. It is worth pausing here to really compare Hyperion to the moons we think we understand well. Our own moon has a stable spin, locked in place so firmly that we always see the same face from Earth. Mars has two small moons, Phobos and Deimos, that behave in fairly predictable ways as well, slowly spiraling closer or drifting apart from their planet over millions of years, but still following orderly, calculable paths. Even Titan, sitting right next door to Hyperion and dominating it gravitationally, spins smoothly and predictably despite its thick orange atmosphere and strange methane lakes. Hyperion breaks that pattern completely. It is the exception that proves just how fragile the assumption of order really is once you introduce the right combination of irregular shape, a nearby massive neighbor, and an eccentric orbit. Scientists sometimes call this kind of behavior a natural laboratory for chaos theory, because Hyperion gives researchers a real, physical, observable example of the same mathematics that shows up in weather systems, turbulence, and other unpredictable natural phenomena here on Earth. There is also something almost poetic about the fact that this chaotic tumbling was predicted mathematically years before Cassini ever confirmed it visually. Jack Wisdom's calculations back in 1984 were built purely on theory and orbital mechanics, long before any spacecraft could actually watch Hyperion tumble in real time. When Cassini finally arrived and captured it, happening exactly as predicted, it served as a powerful reminder that even the strangest, most chaotic corners of our universe still obey mathematical laws, even if those laws produce outcomes that look completely random to the human eye. And that brings us back to the electrical shock, because in many ways, that discovery fits the exact same theme running through this entire moon story. And nothing about Hyperion behaves the way our intuition expects. A moon with almost no gravity should not be able to hold together at all, yet it does. A surface bombarded by chaotic impacts should look messy and eroded over time, yet its craters stay crisp and sharp for billions of years. And a small, icy, atmosphere-free object drifting silently through the dark should not be capable of reaching out and touching a passing spacecraft with real measurable electricity, Yet it did exactly that in 2005, and we only fully understood what had happened nearly a decade later. The discovery that a small, icy, seemingly insignificant moon can reach out across 2,000 kilometers of empty space and deliver an electric shock to a visiting spacecraft from Earth shows us just how much we still genuinely have to learn about the way celestial bodies interact with the environment surrounding them. As we continue gazing outward towards Saturn and its enormous, diverse family of moons, Hyperion remains one of the single most fascinating targets in that entire system. A world that refuses to sit still, refuses to be accurately predicted, and refuses to be anything other than its own strange, chaotic, and genuinely beautiful self, tumbling endlessly through the darkness a billion kilometers from where you are sitting right now. If a moon this small can hide this much mystery, imagine what else is still waiting out there in our own solar system, quietly tumbling in the dark, waiting for the next spacecraft to finally notice.